Welcome to The Explainer. I am so excited to be diving into this with you today. We're going to be focusing on a pretty crucial transition in any developer's journey, which is leveling up from your basic, everyday SQL to the advanced MySQL techniques you absolutely need to handle massive real-world web applications. Specifically, we're unpacking the core learning outcomes from Week 5's curriculum. We're talking about mastering joins, subqueries, aggregation, indexing, and stored routines. So if you're looking to design databases that can literally scale without breaking a sweat, you are in the exact right place. You know, there's this great quote directly from our source material that says, as web applications grow in complexity, so does the structure and behavior of their underlying databases. And I think that just perfectly captures why we're doing this today. I mean, basic select star from users queries, those are great when you're just starting out. But what happens when your app goes viral? When those everyday queries just aren't cutting it anymore? You need real firepower to maintain performance, automate tasks, and hit true scalability. So here is our roadmap for today. We'll start with beyond basic SQL, then connecting data with joins, followed by subqueries and aggregation. After that, optimizing speed with indexes, unlocking database automation superpowers, and finally, putting it all together in the airline ticketing challenge.
Let's kick things right off with Section 1, Beyond Basic SQL.
We are officially stepping out of the sandbox here. It's time to push the limits of those standard queries and really understand why we need these advanced features. Just think about this for a second. What actually happens when your app scales and data is just everywhere? It's kind of like a teenager's messy bedroom, right? You've got users in one table, their orders in a pile on the floor in another, shipping details shoved in a third, and product inventory somewhere else entirely. You get these massive data silos. And basic queries, they just can't easily bridge those gaps without taking a huge toll on your system's performance. You desperately need tools that give you performance optimizations, automation for the repetitive stuff, and the scale to manage millions of rows seamlessly. And that brings us right to Section 2, connecting data with joins. So this is exactly how we solve that first major problem of data silos, retrieving complex, related data that's been scattered across multiple tables. What is a join? Well, by definition, a join combines data from two or more tables based on a related column between them. The source text uses a really fantastic practical example for this. Imagine you have an employees table and a departments table. Your employees table has a dept ID, and the departments table has a matching ID. A join acts as the bridge between the two, so you can pull an employee's name right alongside their actual department name in one single incredibly clean query. Okay, let's dive into this a bit more, because not all joins act the same way. First up, we have the inner join. Think of this one like a super strict bouncer at an exclusive club. It only returns records if there are matching values in both tables. So if an employee isn't assigned a department yet, they don't show up, period. But then look at the left join. This one is way more inclusive. It's the friendly bouncer who lets you in even if you aren't on the VIP list. It returns all the records from the left table, so absolutely every single employee, and any matched records from the right table. If an employee doesn't have a department, they still show up. They just have a blank space for their department. Time for a quick pop quiz. Which join returns only matching rows from both tables? Take a second. Yep, if you said inner join, you hit the nail on the head. For sure, it's the most common join you're going to use when you need guaranteed, complete relationships between your data points. Let's keep the momentum going with Section 3, subqueries and aggregation. Now that our tables are talking to each other, we need to know how to filter dynamic conditions and crunch some truly massive data sets. We'll start with subqueries. And honestly, a subquery is exactly what it sounds like. It's a query nested inside another query. You can drop them right into select, from, or where clauses. Imagine you want to find all the employees who work specifically in the HR department, but you don't know HR's exact department ID off the top of your head. You can just nest a secondary query to say, hey, select the employee's name where their department ID equals whatever the ID is from departments where the name is HR. It dynamically figures out the ID on the fly. It's super clever. Now, what if you need to summarize all that data? That's where aggregation functions come into play. MySQL gives us some incredibly powerful math tools right out of the box. Count simply tallies up the number of rows, which is great for finding your total number of employees. Sum adds values together, perfect for calculating, say, total payroll. Average calculates the average, maybe for employee salaries. And min and max, they just find the lowest and highest values in a data set. Basically, you're making the database do all the heavy lifting, so your application code doesn't have to sweat it. Which naturally brings us to Section 4, optimizing speed with indexes.
So we're joining tables and nesting queries all over the place. How do we keep this newly complex math from slowing down the app? 2 words: database indexing. The concept here is beautifully simple. It improves the performance of your select queries by allowing lightning-fast lookups. Think of it literally like the index at the back of a massive textbook. Instead of reading every single page to find a specific topic, you just flip to the index, find the exact page number, and boom, you go straight there. In MySQL, creating an index on a column, like a user's email address, speeds up searches exponentially, especially when you're using those columns in where clauses or as your join keys.
And actually, this is absolutely crucial, so pay attention here. Warning, over-indexing can actually slow down your database. This is a massive, massive trap for newer developers. Every single time you insert or update a row in your table, MySQL also has to go and update every single index associated with that table. If you index every column just to be safe, writing new data becomes this incredibly sluggish, heavy process. You always have to balance your read speed with your write speed. All right, let's unlock some magic in Section 5, Database Automation Superpowers. This is where we introduce the final set of tools to put your database on absolute autopilot. Let's break down the difference between a view and a stored procedure. A view is essentially a virtual table. It stores a complex select query for reuse. So if you have this massive, ugly join that you use all the time to find HR employees, you just save it as a view. Then you can query that view as if it were a clean, simple table. It totally abstracts the complexity. A stored procedure, though, goes a step further. It's a saved, reusable set of SQL statements, meaning it can execute actual logic. You can call a stored procedure to calculate and return the total employee count without having to rewrite that logic every single time in your app. And then we have triggers. I love these. They are purely chronological cause and effect engines. Step 1, a specific event occurs on a table, like an insert, update, or delete. Step 2, a triggered action executes entirely automatically in response. For example, you can set a trigger so that the exact moment a new employee is inserted into the database, it automatically fires off an insert into a completely separate logs table with a timestamp. The database just manages its own bookkeeping. Let's look at our real-world application directly from the source text. To put that into perspective, how would you use a trigger in an e-commerce system? Well, imagine a customer buys a product. An order record is inserted. You could use a trigger to listen for that new order and then automatically deduct the purchase quantity from your totally separate inventory table. No extra application code needed. The database handles the inventory sync instantly and flawlessly. Let's put everything we've learned together in Section 6, the Airline Ticketing Challenge.
Let's ground all this theory in the real world, because the source material culminates in this fantastic practical assignment: building an airline ticketing system. This is basically the boss fight where all these advanced Week 5 techniques come together. Here are our requirements. We need to create passengers and bookings tables. We've got to use an inner join to match them up. We need a subquery to filter for specific flight destinations. We have to design a stored procedure to handle inserting new bookings. And finally, we need a trigger to handle automatic status updates. Let's see how our new superpowers solve this whole shebang.
And this brilliantly illustrates the data retrieval side of the challenge. First, the inner join cleanly links the passenger names to their booked flights, bridging those two tables perfectly. Then we drop in a subquery. Instead of pulling literally all the flights, the subquery dynamically looks up the flight ID for Manila, allowing us to instantly retrieve only the passengers headed to that specific destination.
Now for the automation engine. We definitely do not want our app handling the messy details of a transaction. So we build a stored procedure that takes the passenger details and safely inserts a new booking. But we don't stop there. We have a trigger waiting in the wings. The exact millisecond that new booking is inserted by the procedure, the trigger fires and automatically updates the passenger's status column in their profile table to booked. It is completely seamless, highly efficient, and entirely automated right there within MySQL.
And that brings us to our final thought for this explainer. You've seen the raw power of joins, subqueries, aggregation, indexes, and automated routines. You've seen them tackle a full-blown airline ticketing system. So the big question to leave you with is, how will you implement these database automations in your next scaling web project? Where can you replace messy, slow application code with a clean, lightning-fast database trigger or stored procedure? Really think about it. Dive into your databases, try out these techniques, and watch your application scale like never before. Thanks so much for joining me on The Explainer, and keep building amazing things.